Yeah, right. So we'll start from my so today, as I mentioned earlier, I was telling you guys that there will be a uh, separate session to cover the light wave section as well. But here I thought of like why not we shall try to complete the whole unit within 2 hours, right? So here I will be briefly explaining about the unit 3 waves and the most important facts. So most probably tomorrow and next few days, we will be able to finish all the other units as well, right? So the next few lessons are actually small lessons. So I might be able to cover at least 2 units within one session. So today we'll try to finish this thing and to refresh our memory, right? Okay, so when it comes to waves, so first of all, before starting these characters and all the stuff, so I have shared this presentation or this note with you earlier. If you don't have it, just drop me a personal message, then I will send it after the session. And yeah. So when it comes to waves, so first of all, you need to know why do we need waves or what are meant by waves, right? Waves. So why do we need it? So you need to remember this definition. And so when we start the lesson, we divided these waves into 2 subcategories. So try to remember them, refresh your memory, okay? So we have mechanical waves and electromagnetic radiation. So the uh, the categorization is based on the use of materials or the particles in the medium, right? Whether we need to use the particles or not. So if we are using the particles, then they will be falling under the mechanical waves, and the other ones will be electromagnetic radiation. So here we are using particles, and here we don't need particles at all, right? So afterwards, mechanical will be divided into uh, transverse waves and longitudinal waves. And under this section, there was a small special point mentioned. So all the electromagnetic radiation will be uh, acting as transverse waves. So don't get confused that they will be also needing those particles. Don't get that wrong idea. So here it will be just uh, existing as transverse waves, right? Okay, so here when it comes to waves and transfer energy and information about all the stuff, so first of all, you need to know what is meant by the transverse waves and the longitudinal waves, right? So when it comes to transverse waves, the particle, if we consider this point, so the particle will be moving perpendicular, right? So you need to include that term here, perpendicular to the wave direction, right? So we did so many calculation questions, question papers, and all those stuff. So you know what I'm discussing here, right? So if there's a question given like this, just imagine they are asking you to uh, draw a setup as well, right? A diagram or something like that in order to describe the wave behavior, right? What are transverse waves and longitudinal waves? So definitely draw a diagram. So though you get the definition wrong, or just imagine there are no important points given in the definition, but then they will consider about the diagram as well. So if you get the diagram correctly, then you will get the full marks. So please pay attention to those points, okay? Then when it comes to longitudinal waves, so the vibrations occur parallelly, right? They occur parallelly to the wave direction. So you need to mention those 2 points. And the important one is don't write they are moving right and left, or in this case, in the transverse wave case, don't write them as moving up and down. The reason is, for example, if we consider the wave direction is like this, and the waves, the particles, just imagine the particle is moving like this from here to here, and then here, and afterwards here. So if we write it up and down, that is wrong, right? We can see here, according to the direction of the wave, this is acting as a longitudinal wave. The reason is like it will be having that parallel nature, right? So pay attention to that. Use the exact correct terms, right? When you're describing, use the exact correct terms, right? And here examples are given, light and sound. Then the characters of a wave. So here, when we discuss about these characteristic graphs, so I mentioned in the theory classes that we can use two different graphs. One is the displacement versus distance graph, and the other one is the displacement versus time graph. So from these two graphs, you will be observing different sort of parameters, right? So in some cases, you can get the wavelength directly from the x-axis, but in the other case, you can get the time period from the x-axis, right? So normally, this displacement will be our y-axis, and this will be our x-axis. So in most of the cases, you will be getting the first type, distance versus displacement graph, right? So in this specific case also, you have the first type, which is the displacement versus distance time graph. And here there's a small mistake. The amplitude arrow must be ending at the zero level, not this part, okay? There's a small mistake there. So go through the definitions, what is meant by the amplitude. So you had so many questions and we have completed them. So I'm not going to take more time in discussing these simple stuff, right? So now the time is very crucial thing now. So you are almost at the uh, exam, right? So you have like 1.5 weeks or something like that, few days, right? So I'm not going to waste your time. So I'm just going to rush these things and try to refresh your memory as soon as possible, right? Okay. So then we have the wavelength. So wavelength, this symbol lambda is being used. So wavelength can be explained here, a peak point to the next peak point, right? Or it can be taken as a draw point to another draw point. So this thing will be also giving you the lambda value, right? So remember those things and all the definitions. And here it is mentioned as a wavefront. The wavefronts are given here, right? So I will be needing another page. So just give me a minute. I need to add another page. Okay. So here, uh, as I mentioned, distance versus displacement. And the second type of graph is the displacement versus time graph. So here we have the displacement and here we have the time. So in this sort of a question, first of all, right, these are the steps. First of all, you need to identify the x-axis and the y-axis, right? First, go through them. Uh, Clearly observe what they have given. And just imagine the graph is something like this, right? So if we consider this point to this point, then we won't be getting the what do you call that lambda value. Instead of that, we are getting a time value, right? So this length corresponds to the time period. So which means the time taken to complete a cycle, right? The time taken to complete one cycle, right? So from here to here also same, and even from here to this point also same time period. Okay, so remember that point. So the important point is that first of all, you need to identify what are the axes, and according to that, you need to give the values, right? Then we have two different terms, frequency and the time period. So frequency is the number of waves that passes single point per second, or you can say number of completed cycles within a given second. And time period is the time taken to complete one cycle, right? Time taken to complete one cycle, right? Then the mathematics. So you need to remember these equations, right? These are some simple equations. So V equals F lambda and frequency equals 1 over T. And always remember, you need to use the specific given units, right? It depends actually. We can't say all the time you need to convert them into SI units or something like that. There are some situations where you have to give the wavelength in centimeters or something like that, right? So before doing the calculation, first of all, check the unit that they are asking, right? Check the unit that they are asking. Afterwards, you can do the calculation, right? So we did so many calculations where you have to convert the units as well from megahertz to hertz and even from centimeters to meters or something like that, right? So please pay attention to these points, right? Otherwise, you will lose 1 or 2 marks. That is right. Okay. Then the Doppler effect, right? So the Doppler effect thing, before, yeah. So here I'll add another page as well, right? Right. So I'll draw something like this, right? So here we are having observer A, and here we are having observer B. So first you have the sound generator or the wave generator at this point. So which means the wave fronts we can draw. So these are perfect circles. Wave fronts are like this. So which means here you will be having the same exact wavelength, right? You will be having the same exact wavelength here, right? So now this sound source is stationary, right? It's not moving towards A or B. But the situation becomes a bit complex, right? When the sound wave the stationary sound object or the sound generator starts to move, right? So just imagine it is starting to move in this direction, right? It can be either the observer or the stationary uh, sound generator, right? It depends actually. It doesn't matter, can be either one. So if we consider this is the initial place where you had the sound source and A is stationary, B is also stationary, right? But now the sound generator, the sound source, we'll say speaker or something, right? It has moved from the initial position like this, right? So because of that movement, what will happen is that the waves will be little bit, we'll say mutated, right? චුට්ටක් විතර වෙනස් වෙනවා. It will be something like this, right? Now what has happened is that this side will be having a low wavelength, right? The We are comparing with the previous case. So you can see that waves are like compressed against each other, right? Concentrated towards B. And here you can see the wavelengths, the wavefronts are actually stretched, right? They are stretched. So therefore, this side will have a higher wavelength and this side will have a low wavelength. So for these two situations, we are using V equals F lambda always, right? So if we use V equals F lambda here, lambda same, V same. So therefore frequency will be same. And for this guy also V equals F lambda, lambda same value, V is the same value. So therefore frequency same. Why did I take V to be same? The reason is in this case, right? In this case, that is the same medium we are dealing with, right? Same medium. So if it is in air, the speed of sound, right? The speed of sound, it is going to be 330 meters per second. And if it is in liquids, it will be something around 1340, right? And in solids like metals or something like that, it will be like, I can't remember the exact value, I think like 600 or something like that, right? So likewise, it changes. And in this case also, we are using V equals F lambda, but here the values are being changed, right? So in this case, if we consider about observer B, lambda gone down, right? It has been decreased, but V value, it is a constant value. Reason, still we are in the same medium, right? Always remember, the speed of sound, it changes according to the medium, whether you are having a denser medium or a low dense medium, right? If it is a low dense medium, then the speed will be higher, right? And if you are dealing with a high dense medium, the speed will be lower. So in this case, we are dealing in the same medium. So these sound waves are traveling towards B and also traveling towards A, like this, in the same medium. So therefore, V value will be same. But here, near observer B, the lambda value has gone down. So therefore, what will happen? The frequency will go up. So therefore, B will hear a higher frequency, right? He will hear a higher frequency. And if we consider about A here, V equals F lambda. So the lambda value, V is constant still again, and the lambda value has gone up. So therefore, frequency goes down, right? So if they ask this situation, this thing in your exams, then you should be able to explain that, okay? Where is it? So you should be able to explain this, right? Okay, then electromagnetic spectrum and right, okay. Then we have to discuss about the electromagnetic spectrum. So you need to know the idea of a spectrum, right? Spectrum means we are dealing with the range here, right? We are dealing with the range. So range of electromagnetic radiation, that is the main idea, right? There's a range, there's a higher point and a lower point, right? So in this case, you can use either to prepare this one, lambda, or you can use the frequency, right? You can use the frequency. So better to remember in this order as well, right? So here you can see the wave is being like, like it is concentrated here, right? So here in this side, you have a higher wavelength, and comparatively here, it is a low wavelength. So again, we are using that V equals F lambda. So if lambda value goes up, then the frequency goes down. Velocity, it is a constant value. So all the electromagnetic radiation will have that speed of light, right? 3 into 10 to the power 8. 3 into 10 to the power 8 meters per second, right? And remember about the properties of electromagnets as well, electromagnetic radiation actually, right? Those reflection and refraction properties, those things, right? So here you will have a low frequency and here it will be having a higher frequency. And there's another important point I mentioned in the theory classes as well. So energy of these radiation will be directly proportional to frequency, right? So therefore, if you are having a higher frequency, then what will happen? Those guys will be having a higher energy, right? Those guys are having higher energy. And this side, you will be having a low energy, right? You will be having a low energy. And actually, this visible range is going like this, right? Remember no need of remembering the values, right? No need of remembering the values. Just remember the order, right? We have discussed so many things about these things and completed so many calculations, questions from this section, right? Uh, so you know about these things, right? You are aware of how the calculations will be there, right? So therefore, I'm not going to take more time in discussing calculation. These are some simple steps I wanted to just refresh the memory, right? So when it comes to here, remember this thing is important in order to get the uh, theory built, right? So remember, the energy depends on the frequency. So if you are having a higher energy, then the frequency must be higher, right? And also remember the order. Okay. Then the frequencies, there are use cases and the harmful effects, right? So I'm not going to go into in detail. At least remember one harmful effect. There are some important things like getting those tissues heated, body tissues heated, like those stuff, right? And also mutilation. So if you are considering about mutation of body cells or something like that, then we cannot use this sector, right? The reason is their energy is low, right? So if it is going to be like mutation or something, then definitely this section will be used, right? So this section can be used to heat the internal body tissue, something smaller, something smaller like that, right? Not like burning the cells or mutating the cells and protein structures or something like that. Okay, try to grab that point. And so as I mentioned, try to remember one use case scenario and harmful effects as well, right? Yeah, the biological hazards are also given, so you can go through them. Then the light wave section. So I will be starting that point as well. So we discussed so many things about light waves. What are the main factors that affecting to the eyesight and all the stuff? So no need of remembering those stuff. But remember the main differences between the reflection and the refractions, right? Uh, so here the incidence angle will be equal to reflected angle. Just remember that thing. No need of knowing that the specific terms, Snell theories or something like that. Even in the classes, I didn't give you those things because in all else you don't have them, right? Specifically, they are not mentioned. But in A levels, you have them. So you are not facing A levels, you are facing all levels. So up to O level knowledge is enough, right? So get the idea of refraction and reflection. And here also you can see in previous cases like before 2017 exams, we had so many things to discuss about these light waves, like even the behavior of lenses as well, right? And even to determine how the images are going to be formed, right? From through the lenses or even through the mirrors or something like that. But in your syllabus after 2017, we don't have them, right? And that is the main reason why I didn't give you those papers, those previously ones, old ones from 2019 to, sorry, 2009 to 2017 papers, that all spec syllabus papers, right? The reason is that thing. So here, no need of knowing how to get these images, but here you can see clearly the reflection theories are being used there, right? And I need to mention this thing. So when you are having, let's say, a drawing to be completed, right? So remember this point. If it is a, let's say, uh, a linear surface, right? Just imagine they have given a linear surface and they are asking, let's say, there's an incoming ray like this, right? They are asking you to draw the, let's say, the normal, right? The normal. So definitely, so that is the first step of a drawing, right? So remember those points. You need to mention the direction, the arrowheads as well. And in order to get the normal, you need to actually measure it by using a protractor, right? So the normal will be always perpendicular to the surface, right? So this symbol means perpendicular, 90 degrees, right? So this is going to be the normal, right? So that is our first step. You need to draw the normal. Afterwards, what you are going to do is you are going to measure this angle. This is going to be the eye angle. Then you are going to measure the R angle. So this is going to be the R angle. And you're going to draw it like this. So this is for a linear surface, right? So this is the linear surface or straight surface, right? Linear surface. But just imagine if it is a curved surface. We came across several calculate questions from this section, right? So just imagine if it is a curved surface like this, right? Now there's an incoming ray. Now they are asking you to complete the diagram, right? Complete the reflection diagram. So again, we are using the same similar steps. So first of all, you need to draw the, what do you call that? Normal, right? So always remember, if you are having any sort of an incoming ray, right? Definitely the normal would be placed at the touching surface like this, right? Since this is a curved surface, right? We cannot just draw the normal. So if it is a curved surface, so remember this point, right? Curved surface, you need to draw the tangent line, right? I think already all of you know what is meant by a tangent line. So tangent is the uh, straight line that you can draw to a curved surface, right? So here you can draw the tangent like this. Afterwards, you are measuring the angle and you are drawing the normal like this. Just imagine the incoming ray is here. Then for this place also, you need to draw another tangent, right? You need to draw another tangent. Then you are going to draw the normal, right? This is how the diagrams are being completed for a surface, which is a curved surface. Afterwards, you are going to measure this angle and you are going to draw it. You are going to draw it. Okay. So remember that point. Remember that point. Okay, so this was actually tested in a past paper. So and another thing that I need to mention is that please within these few weeks refer the past papers that we did, right? 2025 November up to 2025 November paper. Please refer these papers once again. Refer means like you are not doing it once again. If you are having time or if you feel like it's better to do another paper, then please do them once again and also check them once again, right? Please pay attention to the papers from 2022 to the most updated one, 2025. And so here you have Edexcel papers, both the mainstream paper and also the regional ones as well, right? So for the regional ones, from 2023 to 2025, right? Or 2024. Please refer them, right? So that is the crucial point. If you need to gain another like a good mark or something like that, there's no point of reviewing all the theory once again, right? So this revision is also something like that. Like there's no need of memorizing all the theory parts once again, but you need to know how to. So you have learned all make a study කරලා තියෙනවා. So you need to know how to get that point out of your brain. That is the main issue. So please go through the question papers at least twice, right? You have like 2 more weeks, ne? So allocate a time, at least like 1 hour or two, so something like that, and try to cover all the papers once again. Just read them through and try to understand the question and within your mind, right, try to get the method. No need of the exact answer, no need of using the calculators or something like that. Just try to think how you can get the answer for this. That's enough. What are the steps, right? No need of the final answer. So try to practice that method for even biology as well. So in biology, you don't have calculations, ne? But try to memorize the answers by looking at the question. Try to memorize the answer. No need of writing and wasting time, right? So please engage in that work. So you definitely you will be gaining another 2 or more marks, right? So that is a well experienced method, right? So here also the Snell law is mentioned, so no need of the name. So remember this equation, most of the students, right? There were several, they were just writing n equals I over r. That is wrong. So remember, you need to get the sign value definitely, right? That is a must. So sin I over sin r. And the most important part when it comes to this light reflection and all the stuff is the total internal reflection, right? Total internal reflection. So remember these points. So if you are going for the total internal reflection, TIR, right? There are two conditions to be completed, right? Remember this point. First point is that the light ray must be coming from denser medium to the low dense medium, right? It must be from denser medium to the low dense medium. So remember that point. And the second one is that in that moment, the incidence angle must be larger than the critical angle, right? So I will explain them once again, but remembering these 2 points is must, okay? This is the most crucial part. The reason is like you have previous experiences. Like when it comes to this light waves question, most of the time they will be starting from the smallest part, like to mention, like to measure the I value or R value, or just to write the refractive index equation, and they will be giving data points to calculate the refractive index like that. But at the end of the question, you might have remembered they will give a specific light wave, and they will be asking whether it is going to be bent or not, or uh, it is going to be exiting the light object, the glass object or not, right? So likewise, there will be questions. So please go through them once again. Definitely you will be getting a question from the total internal reflection, right? Normally, ඒක එහෙම තමා වෙන්නේ. There will be a part from the total internal reflection. Otherwise, there's no point of giving a question from light waves. හරිද? එහෙම තේරුවක් නැහැ. අනිවාර්යෙන් total internal reflection calculation එකක් එක්ක light ray එකක් judge කරන්න එනවාමයි. Right? So please pay attention to these points. And so here, as I mentioned, it will be going from the denser medium. So this is the dense medium, and this is the low dense medium, right? So here you can see the light ray is coming from the dense medium. So this is the direction. So the light ray will be coming from denser medium to the low dense medium. Before approaching the critical angle, I will say something like this, right? So if I use this light ray, right, this is the first one, and it will be going like this, right? So this is the normal. It will be bent away from the normal. Once I increase this angle, right? Once I increase this angle, I'll use another color here. Just imagine something like this, right? I have increased the angles value. Then again, it will be bent away from the normal. And once it reaches this critical angle, this special moment, right? This critical angle, special moment, what will happen? So this ray will be further bent away from the normal, and eventually it will be going through the margin of the surface, right? It will be going through the margin of the surface, making the refracted angles value 90. So that moment, that is known as the critical angle, right? So as I can remember, there was a question asking what is the critical angle, right? So you need to mention it, right? So just remember the diagram. That's enough, right? So I'll erase these things so then you can clearly get the definition. So try to remember the definition. So critical angle is the angle where the refractive angle is 90, or you can say the light wave is going through the margin, where the light ray is going through the margin, right? So once after, if we increase this critical angle, මෙයාට චුට්ටක් වැඩි කරනවා මම මේ විදිහට. Now what will happen? It will be also bending away from the normal. Now it will be acting as the reflection theory, right? Now it will be bent like this. So that is mentioned in this diagram, okay? Now it is mentioned like this, right? So now it will be following the reflection theories, making the incidence angle and the reflected angle equal to each other, right? Equal to each other. And there are some equations that you need to remember. There's no need of remembering how to get this equation, but this is the most important equation is the critical angles value, right? The critical angles value. So it will be something like this. N sine C will be equal to N air, this is N glass, into sine 90. This is how we are going to get the equation, right? So how did I get this equation? I am following this arrow's direction, right? In case if you forget the equation, that's why I am telling you this. Otherwise, no need of remembering this equation, right? In case you forget it, you are going to take it like this. Follow the arrow's direction. So starting from the glass medium. So refractive index Ng into its sine value, sine C. That will be equal to in the other way around. So now the light wave is going through the air medium. So that is N air. The refractive index is air into its angle sine 90. So here Ng sine C will be equal to, in normal cases, the refractive index of air will be considered to be 1, right? This is something like relative matter, right? ඒ කියන්නේ අපි මෙයාව relate කරලා තමයි ගන්නෙ. Therefore, we consider uh, this air's refractive index to be 1. That is a standard value, okay? So this is going to be 1. And if you check the sine 90 value, it will be also 1, right? Sine 90 value will be also 1. So therefore, you can say the refractive index of glass will be equal to 1 over sine C, right? You can memorize it by this way, or you can memorize it sine C equals 1 over n, right? And always remember, if you need to calculate the C value, then you need to get the sine inverse value, right? Sine inverse 1 over n. So how to get the sine inverse value in the calculator? You need to press Shift, then the sine button, right? So remember these points. Okay, this is how we get the equation for the critical angle. No need of remembering this, but I gave you the method in case you forget it, right? And these are the two equations that you can remember, okay? Right. All right, it's given here also. And routing data through optical fibers, it was actually given in your textbook. This is a use case situation scenario, so please go through it, how it is happening. So total internal reflection is the main thing that we are using, right? So here you can say the light ray is entering, and this medium is going to be, the inner surface is going to be the denser medium. And here air is the low dense medium. So which means the factors affecting the total internal reflection has been fulfilled, right? You need to have the light ray traveling from denser medium to low dense medium, right? Denser medium to low dense medium. So therefore, what will happen until it exit through the fiber line, it travels like this, right? If somehow, just imagine the density changes, it rarely occurs. Or the next factor is that you're going to change the angle. So just imagine you are using a low angle than the critical angle. Then what will happen? There will be this refraction, right? So I'll write down those 2 points. If you need, you can mention them. So the first point is that density change, right? If there's a density change, then this light ray might exit like this, right? This is a rare case actually. Normally, density change is a rare case. Density change of the material of this fiber, right? Density change of the fiber. That is a rare case. And the second most favorable one, right? වෙන්න පුළුවන් එක තමා මෙන්න මෙයා. The incidence angle might be lower than the critical angle. But if you need to have the total internal reflection, see, incidence angle must be higher than the critical angle, right? It must be higher than the critical angle. But in this case, you can see incidence angle is lower than the critical angle. So therefore, what will happen? You will be experiencing the normal refraction process, right? Normal refraction process. So therefore, light ray might exit. So therefore, in these type of situations, if you need to like, transfer these light rays through this optical fiber, so these calculations are done, right? They will be calculating the critical angle. So can't we calculate the critical angle? We can. If we know the refractive index of this material, we can calculate the critical angle, right? So depending on the critical angle, uh, we can give the light ray at that desired angle, right? So remember these points. Applications, yeah, applications and all the stuff, right? Then mechanics of sounds and hearing. So remember the human hearing limit, right? And measuring the speed of sound using the echo formula, right? So for that point, all right. So here we have a small part. මම මේක ඉවර කරලා ඊට පස්සේ තව ටිකක් discuss කරන්නම් මේ ටික. Remember about the pitch and loudness, right? So use the textbook and try to remember them. And for this thing, measuring the sound, the distance, right? So okay. So in order to measure the distance of the sound, so we are using the echo, right? We are using the echo process. So echo means, just imagine this is the sound generator and the sound waves are going like this, right? They will be sorry, not transverse waves, longitudinal waves, but in all right, I'll draw it like that. So it will be traveling like this and hitting the barrier, and then it will be reflected back, right? So by using this method, so this is known as echo, right? You will be hearing the same sound. Uh, so using this echoing method, we can measure the distances, right? So the common case is number one, measuring the depth of the sea, right? So here you have the vessel here, and just imagine this is the seabed, right? So this will be emitting sound waves like this. So therefore, you need to have an emitter, a sound emitter. It will be, the sound waves will be hitting the seabed, and then it will be traveling back. And here you need to have a receiver, right? So both emitter and receiver must be there. Both emitter and receiver must be there. So here we will be measuring, you can, yeah, normally we measure the total time taken, right? Total time taken. The total time taken. We'll say it is T. And if we consider the depth to be X, right? Then, so we can say the sound speed in water to be V, right? The sound speed in water is V, right? All the sound waves have the same speed, right? It doesn't change. As I mentioned, it will be changed upon the medium, right? If the density changes, then the sound wave, the speed will change. For example, let's say you are using seawater and fresh water, right? So definitely there's a density change. So therefore, you will be having different speeds for these seawater and the fresh water, right? Okay. Then we are using the linear motion equations here. So is speed, we can write. So the speed equals distance over time. The speed equals distance over time. So speed going to be V. Now the distance, right? So you need to think about it, right? So this is the place where most of the students get the wrong approach, right? So here the sound wave, so it will be emitted first, travels X distance downward, then reflects and travels another X distance upwards, right? X එක පල්ලෙහාට ගිහිල්ලා then you will get another X upwards. So the total distance is going to be 2 times X, or you can say 2 times as the distance, right? And in this case, we are measuring the time, total time. So the total time for this motion is T. So therefore, the depth value will be equal to Vt over 2. No need of remembering these exact equations. Just try to get the concept there. Okay. Try to get the concept. And the same thing can be taken to measure the distance between two walls or something like that. So same thing, we have the sound generator and this is our wall. Just imagine this distance is X, right? And the total time taken for this echoing process to be T. So again, we are using speed equals distance over time, distance over time. So the speed, now it is air, speed of air speed of sound in air, speed of sound in air, it will be equal to distance. So in the echoing process, what has happened? Distance will be doubled, right? Has to travel x distance and to return again. So therefore, it will be 2x over t. So therefore, the distance between the wall will be Vt over 2. You will get the same equations as in the previous case, right? So my advice is not to remember these specific equations, but remember the theory that we are using, right? So the theory, the main theory behind these wave is the reflection theory, right? You need to get the reflection in order to have this thing. Just imagine you can't reflect these waves or anything like that, then definitely these methods cannot be implemented, right? So remember the theory, not the equations, right? So these are some practical things now. And even in physics and chemistry, we are using the applications, right? So there are so many applications. We cannot by heart them or memorize all the applications. So then it will be a subject like biology or something like that, right? So these are thinking subjects, critical thinking subjects. So therefore, you need to improve your thinking patterns, right? Okay, so here, and I forgot to mention if you're having any questions or problems, so you can use the chat box. Huh? I am using an external mic, so I can't hear anything that you say. So if you're having any trouble, you can even drop a WhatsApp message, personal message, or you can use the chat box to communicate with me, right? If you're having any sort of problems. And yeah, that's up to sound waves. So remember the human hearing range. We did so many questions, right? And most of you have a good results, I think, right? As I can remember, you got good marks actually. That's happy to hear actually, right? So I want you to maintain that thing until you face the exam, right? So try to aim for that band 9. You all can, right? uh, Pay attention to those small mistakes like having like unit conversions and all the stuff, right? And I have given you so many, yeah, like exam tips as well, like don't get stuck in the same question for long, right? If you feel like you can't remember this thing, this theory or something like that, then just go to another question, right? So use those methods. And there's another thing that I want to explain here. Mm, Using this reflection and reflection thing. All right, so here, right. So in order to like, in laboratory, in order to demonstrate this reflection and refraction, we are using a setup called ripple tank, right? Ripple tank. So I'm not going to go in detail description of the ripple tank, but here this thing can be used to uh, demonstrate that refraction and reflection. So if you are going to mention or demonstrate the reflection theories, then so you can use a bar wave generator, or you can use a tiny uh, pointer to generate waves, right? So if it is a bar wave generator, then you will be getting waves like this, right? The wave fronts will be like this. And if it is a tiny pointer, then you will be getting waves like this, right? And just imagine you are facing the barrier here, right? A rigid barrier. So the reflection waves, the reflected waves, right? So they will be having the same wavelength as well, right? You will be having the same wavelength. And in this case also, you will be having the same wavelength. And here you need to remember the wave patterns, right? Wave patterns. So if we adjust this barrier in a specific angle, then you will be getting different sort of wave patterns, right? In the theory class, I gave you the workbook, and there were like as I can remember, there were like 3 or 4 wave patterns, right? So please go through them, and even in your textbook as well, they have mentioned those wave patterns. When you angle, right? When you angle this barrier, then you will get different wave patterns, right? Uh, there might be a question, but I can't guarantee, right? So like even from 2019 onwards, there was no question related to this ripple time, as I can remember, right? So pay attention to that. Okay, you might get a question. And the next one is the refraction thing. So in order to get the refraction, the main concept is you need to have different densities, right? Different density. So in order to make a different density region, right? Just imagine this is the ripple tank, the cross section. And here, what I'm going to do is I'm going to place a wooden block or any sort of a material, a dense material at a certain place like this, right? So now what has happened is here, this region and this region are two different ones. So this will be acting as the deep region, and this will be acting as the shallow region, right? So from here onwards, it will be acting as a shallow region, and this is going to be the deep region. And if you have the pointer here, the wave generator, then what will happen? There will be waves generated, and once after they are enter into the shallow region, now the wavefronts will be changed, right? So if we look from above, so this is the shallow region. So here you will be getting the waves like this, let's say in lambda 1 wavelength. And once after they are enter into the shallow region, what will happen? Their wavelength will decrease like this. So they will be getting lambda 2 wavelength, right? So in order to explain that difference in wavelength, we are going to use the equation V equals F lambda, right? V equals F lambda, right? So density we'll say something like this, right? So velocity, it is inversely proportional to density, which means if you are having a higher dense medium, right? Higher dense medium, then the velocity will be lower, right? Density, if the density is higher, the velocity will be lower, right? So if we consider about the deep region, right, you can see the water molecules, and like no need of going into that molecular level. Just remember, deep region is the place you have the low density, right? It is low density. And the shallow region is the place that you are having the high density. Just remember that point, okay? So high density means low velocity. So therefore, velocity at deep will be lower than velocity than the shallow region, which means at shallow region, oh no, in the other way around, right? Velocity at the deep region will be higher than the velocity in the shallow region, right? So we are using this concept in order to explain why we are getting different lambda values. So we are using V equals F lambda equation. So what can you say about the F value? So it is going to be a constant. The reason is we are using the same generator, right? We are using the same wave generator. So which means the frequency is a constant value, right? Frequency is a constant value. So therefore we can say the lambda will be directly proportional to speed, right? This is because the wave generator is same. The wave generator is same, right? So therefore lambda will be directly proportional to V. So which means if we take the shallow lambda value, it will be directly proportional to the speed of the shallow region. If we take the shallow of the deep region, it will be directly proportional to the velocity of the deep region, right? So here you can see the deep region is having a higher velocity than the shallow region. So therefore, finally we can say lambda d will be higher than lambda s, which means the shallow region will be having a low velocity. So that is the main reason in beaches, right? You are not going to experience like huge waves. There are some situations where you have huge waves, but most of the time you will be experiencing smaller waves, like even some cases like just 1 meter height or something like that, right? The reason is that, so when it comes to the shallow region, the density is higher. So therefore, the speed drastically reduces. But if you go to the deep region, right, you might have seen this in videos or in movies as well, like there are huge waves, and the wavelength, like in some cases wavelengths are like this, but when it comes to the beaches, the waves are like this, and the ships are going up and down like that. You might have seen those videos, right? So that is the main concept behind this shallow region and deep region thing. So uh, just go through these notes, right? All the notes are given there in your theory notes as well. So please refer them again. The reason is like they haven't asked this question about this ripple tank. And here another thing, when it comes to the light waves, uh, let's say I'll discuss about the practical as well, right? A general practical. So, right. So normally, when it comes to the practical, the normal thing that we are going to do is something like this, right? So we are using an A4 paper, right? So this is the typical practical actually. This is the A4 paper, and we are going to place the glass block. Just imagine we are using a glass block. So uh, this is to determine refractive index of the glass, right? Refractive index of the glass. So we are going to place the glass block like this. Then we are going to draw around it using a pencil. We are going to draw the margin of it on the A4 paper. Then we are going to remove the glass block. Afterwards, I'm going to place a pin here, right? And oh no, we'll do something like this, right? We can draw the normal like this, and I'm going to measure an angle. Let's say I'm starting with 30 degrees, right? So I have drawn the path, and on that path, you can place pins, one closer to the glass block and the other one somewhat away from the glass block. So instead of using these pins, right, you can use a laser box as well. So instead of drawing these stuff, these lines or anything like that, you can directly use a light box actually. Laser box, light box, or all are correct. The correct one is the light box, right? You can use a light box. And the thing that you're going to do is you're going to observe from the other side, right? Not the side A. You're going to observe from side B, and you are going to place your eye like this, and you are going to see whether you can see the pins or the light emitting from the light box. So if you are using a light box, then the light box would be here, right? And these two pins won't be there, right? So you will be observing, and that observed line, just imagine it will be like this, right? It will be coming to your eye like this, right? Okay. Then here you are going to place another pin and another pin. Then you are going to remove the glass block. So you have the path of this light. Then you can connect those two paths. So this is our I value. and you can measure this value. This is going to be R value, right? So likewise, you are going to continue up to like, let's say 30 degrees, 40 degrees, 45, 60, 90. Likewise, you can, no need of 90, 60, 65, 75, likewise, right? So you are going to get these values and you are going to prepare a table, I value and the R value. Then you can get the refractive index sine I over sine R, right? And even you can draw a graph as well. So if you draw the graph, you can take sine I values here, sine R values in the y-axis. So the graph would be something like this, right? Never mind. Then if you calculate the gradient, then it will be, uh, gradient will be sine R over sine I, which means this is going to be 1 over n, right? 1 over n. If you want the direct sine I over R, then you need to change the x and the y axis, right? So depending on that, you can get the answer. So remember, this thing can be done. And just imagine uh, you need to measure the critical angle of a given glass equipment. So for that, for the critical angle, we are doing like we are using a glass block, something like this thing, a semicircular one, right? So same thing will be done here. So this is the A4 paper, and here we'll do something like this, right? So here I'm going to draw the margin like this, and I'm going to draw the normal as well, right? Then we are using the glass block, the light box, right? So let's say the first angle, I'll take 30 degrees like this. I'm going to place the uh, light box like this, and I'm going to observe from this side, right? I'm going to observe from this side whether I can see the light ray emitting or not. So let's say the critical angle for this material is to be 45. Let's say just imagine 45, right? So at 30, what you will observe? A light ray emitting like this, right? Now I'm going to change the angle. Let's say I'm going to 40 degrees, right? I'm going to 40 degrees. So still I will be observing something like this. And once it is set for 45, then you will observe that this light ray is exiting along the margin of the glass cube, right? So now you will be observing something like this, right? So for this sort of a practical, just imagine if you have to measure the critical angle, then there's no need of repeating it, right? So it's okay to repeat, but in the previous case, we had to have like different angle values. And depending on the different angle values, we will be calculating different refractive index values. Then we will be getting a average value or something like that. So in here, like determining the n value from a single value, you can get the answer, right? Whether you are going to repeat it or not, you can get the answer just by having just one angle only, right? එකකින් විතරක් එක setup එකකින් කියන්නේ එක අපි තුමු angle එක 30 වලින් විතරක් වාක් කරා කියලා, still you will be getting the n value. If you do it for 40, still you are getting the something similar to the previously calculated n value. But here we cannot get that approach. We need to change the angle and we need to see for ourselves what will be the critical angle, right? And just imagine you have increased this one to 45 point something, 45.1, or let's say 46 degrees. So now what will happen? Then you will experience the total internal reflection thing, right? Now you will experience the total internal reflection situation, right? So try to understand the difference between these two practicals, okay? So if you are measuring the critical angle, then you need to change the angle and see for yourself where I can observe the critical critical moment. So this moment, actually, this green line, this is known as the critical moment, right? That is the most important part. So in order to get the critical moment, you need to change the incidence angles values and see whether, right? What is going to be the critical angles value. But in this case, there's no need of changing the values. Still, you can get the refractive index by using just one or two data points. But since this is an experiment, it's better to use at least five or at least three data points to calculate the reasonable value, right? Okay, so yeah. So the most important part in this wave section is that the light waves thing, right? As I mentioned, you will be getting different sort of calculations. It might be to like a practical or something like this, or it can be something like let's say a calculation or something like that, right? Uh, those are the things that you're going to get for the exam. So yeah, that is end for the waves section. So just tell me if you're having any sort of problems, just use the chat, okay? So is there anything that I need to clarify once again? Like if there are anything that I need to discuss more rather than this thing that you feel like you need to refresh your memory upon that theory discussion or something like that? Any specific part related to this wave section? Yes, you can use the chat. Or if not, we can wind up the session. So that's all. If the time, sorry, if the distance double, does the time also double? No, Sadaham. So here, we are measuring the total time, which means the time taken to uh, emit from the equipment and then to receive it. We are measuring the total time. So if just imagine if you are using the half of the distance, then the t will be also half, right? We are measuring the total time. So always just stick to a one part, right? So you are measuring the total motion, right? So which means you are measuring the total time taken, which means emitting and the time taken to receive, right? To emit and to receive, to emit and to receive, right? So that is the total time. In that case, the total distance would be x, then another x, right? X and another x. So which means total distance is 2x, right? So remember this part. This is the most important one, right? Yeah. Is there any other questions or yes? Yeah, welcome. So if you're having any sort of questions or any clarifications to be made, please do contact me, right? I am available, so I am happy to help you guys. So somehow I need to see good results. That's the main thing. So if you're having any sort of trouble, just drop me a WhatsApp message, a personal message or something like that. Then I will be able to help you guys. So yeah, so that's all for wave section. And if I missed anything, so please just tell me. So then I'll arrange another 1 hour or some sort of a session and I'll discuss it. Okay. So that's all for today. And so I won't be taking more time. So please go through this stuff and try to refresh your memory. And as I mentioned, please engage in more and more question reference, right? So please refer the question papers, the past paper question tutorials which I have given you. And even there were some papers which I prepared as well, as I can remember for the term tests or something like that. And so please go through them. I'm not asking you to do them from the beginning once again. I want you to read through the question and try to think, right? Think in your mind how I can do this calculation. And if you're having any sort of trouble, any problem in those calculations, any questions, just take a photograph and send me and ask me how to do it, right? So I will be able to help you. And so, as I mentioned, if you're having any trouble, just ask me, right? So, is there anything else, or otherwise we can wind up the session? You can utilize this time as well for your studies, right? Okay, so it seems like it's okay. And remember, if you're having any trouble, doesn't matter the time. Don't call me first. Just drop a WhatsApp message. Okay. So that's all for today. And thank you for joining. And have a blessed day. Right. So utilize this time. Okay. Okay. So thank you for joining, and have a nice day.